Good day. This is the fourth chapter of our lesson, which is functions and relations. So in this chapter, you will learn different types of functions and also relations that can be considered as functions or not. Let's proceed to the next slide. For the introduction, this lesson contains kinds and types of relations and how functions in mathematics. Learners will also know how does the functions and relations used in the modern world. For the learners, you should be able to discuss the language, the symbols, and convention of mathematics that are used for solving the functions and relations of mathematics in the modern world. So let's take a look of this example. For example, you as yourself, what is your uh, relationship to your parents, or what does it call? Of course, we can call it as mother-daughter, or father and son, or father and daughter relationship. Another example, you as yourself, as a person, what will be the term that we are used to connect with our friends? Maybe we call them as best friends or close friends, okay, or friends that someone you can trust. That is how we call the relationship with them. And of course, if you as a person and you are connected with me because I am your instructor in mathematics. So there is a student-teacher relationship. And these three examples is what we call relations. So when we say relations, there are two same kinds that have been connected with each other. Okay? So parang may kinalaman ng isa't isa. Right? So let's proceed. There are many relationships in the world, of course, katulad ng example natin kanina. So, similarly, objects of mathematics may be related in various ways. So, for example, a set A can be related to set B if there is a condition given. Okay, let's take a look at this example. Let set A, the elements are 0, 1, and 2, and set B, we have 1, 2, and 3. So, in this example, sabi, element X will just be in set A. So, meaning to say, etong 0, 1, and 2, eto yung ating mga X. And set B are the element Y. So, ito yung mga Y. Related lang sila if and only if X is less than Y. So, it should be X less than Y. So, how are we going to justify or solve it? So, we can write it in this way. So, etong mga first numbers, these are set X or set in set A. So, 0, 1, and 2. Ito yan, di ba? Yung mga X. And then, the second number will be the set element Y. So, if we have the first coordinate 0, 1, so 0 should be related to 1 since 0 is less than 1. Sinasatisfy niya yung ating condition. Okay? Ganun din dito, and 0, 3, and then 1, 2, 1, 3, and 2, 3. Why is it 1 is not related to 1? So, ang coordinate nito is 1 and 1. Because 1 is not less than 1. It should be 1 equals 1, right? Ganun din naman dito. 2 is not related to 1 since 2 is not less than 1. It should be 2 is greater than 1. And then, ganun din sa kabila. should be 2. Sorry, this is 2. Is not less than 2, or 2 should be equal to 2. Okay, so we have uh, how many not related coordinates? We have 1, 2, and 3 only. Okay, so before we proceed on getting the relation of set A and set B, let's get first the Cartesian product A cross B. A cross B are the set of ordered pairs such that X is an element of A and Y is an element of B. So we have A cross B is equals to the set of 0, 1. Let's recall the set A, we have 0, 1, 2, and set B are 1, 2, and 3, right? So next will be 0, comma 2, then 0, comma 3. We also have 1, 1, 1, 2, and 1, 3. Next is 2, 1, 2, 2, and 2, 3. So these are the A cross B. Consider that this all set of all ordered pairs in A cross B whose elements are related to. We had this last in the previous slide that X should be less than Y, right? To consider that they are related. So we will symbolize it as R for relation of A cross B. So we have equals, again, it should be equal set of 0, comma 1, 0, comma 2. We also have 0, comma 3. We also have 1, comma 2, 1, comma 3, and then 2, comma 3. So these are the relations of set A and set B. Let's proceed to the next slide. With that, let's define the relation. Let A and B be the set. So A relation R from A to B is a subset of A cross B. Given an ordered pair X, comma Y in A cross B, let's remember that X is related to Y by R, or by relation. So written as X, capital letter R, then Y. If and only if the ordered pair X and Y is a relation. Okay? It depends upon the given, or the given of the given problem. So the set A is called the domain of R, and set B is called its codomain, or in other books they call it as range. Okay, let's take a look of this example. Example number 1. So this is about a relation as a subset. So we have here the given, which is set A. The elements are 1 and 2, and the set B, whose elements are 1, 2, and 3. Define a relation R from A to B as follows. So this is the condition. Okay. Given any ordered pair X and Y element on A cross B, which is equal to uh, ordered pairs X, comma Y is a relation R, means that, so let's highlight it, X over 2 is an integer. When we say integer, the answer for x minus y over 2 should be a whole number, either negative or 0 or positive numbers. Okay? So this is the condition. We have here three questions. First, sabi dito, state explicitly which ordered pairs are in A cross B and are in R. Okay? So we will list down all the elements of A cross B, and we will identify which are the considered as relation ordered pair. Okay? Second question, is 1 related to 3? Is 2 related to R? Is 2 related to 2? So we will try to identify if it is yes or no. Then 3, or letter C, what are the domains and codomains of R? Okay, let's have the first question. Remember that our given A is 1 and 2 and B is 1, 2, 3. It will be R if and only if x minus y over 2 is an integer. Okay, so the first question is state the explicitity of A cross B. So yeah, we will try to list down it downwards. So let's identify, let's take a look first of 1, comma 1. Is this relation? Let's try. 1 minus 1 over 2. So this is 0 over 2. 0 divided by 2 is 0. Therefore, 1 comma 1 is an element of relation. Okay? Because the answer is an example of integer. Okay? Let's proceed next. 1 comma 2. Let's try. 1 minus 2 divided by 2. So this is negative 1 over 2. Negative 1 over 2 is simply a fraction, or it can be converted into decimal as negative 0.5. Therefore, the ordered pair 1 comma 2 is not a relation. Okay? Then, let's proceed to the next one. We have 1 comma 2, 1 comma 3. Let's try it again. 1 minus 3 over 2. So this is simply negative 2 over 2. This is negative 1. So this is a relation. Okay. Next, we have 2 comma 1. So 2 minus 1 over 2. This is 1 half. So this is also equivalent to 0.5. So this is not a relation. Next, we have 2 comma 2. So 2 minus 2 over 2. So this is 0 over 2, or simply 0. This is a relation. Next, we have 2, 3. So we have 2 minus 3 equal over 2. This is negative 1, right? Over 2. Therefore, negative 0.5, this is not a relation. Okay? Then, let's have the second, so this is our answer in letter A. The answer in letter B is 1 related to 3, right? Is 1 related to 3? Let's try. So this is 1 related to 3. So this is yes. Then is 2 related to 3. Let's see. So 2 related to 3. Our answer is no. So this is not related. Then last is 2 related to 2. So our answer should be yes. Okay. In letter C, the question is, what are the domain and codomain? So it's simply set A are the domain and set B are the codomains. So domains are set of 1 and 2. And codomains are 1, 2, and 3. So this is how we perform the relation of uh, two sets. Then here, we have the next topic, which is about arrow diagram of a relation. So suppose R is a relation from set A to set B. The arrow diagram, so it means that this is an illustration, okay, for R is obtained as follows. The first one is to represent the elements of set A as points in one region. So parang if this is set A, so ganyan siya, parang andito yung mga elements niya. And the elements of set B as points in another region. So something like this. Okay? Then, yung arrow diagram, something like that. Okay? For each x in set A and y in set B, draw an arrow from x to y if and only if, of course, there will be the condition that x is related to y by relation. Symbolically, so x is x, capital letter R, y, or the ordered pairs x and y is an element of relation. Okay? Let's have this example. Let A, whose elements are 1, 2, and 3, and B, whose elements are 1, 3, and 5, define the relations S and T. Okay? From set A to set B as uh, follows. For all ordered pairs, x and y is an element of A cross B. So the first question would be x comma y, or ordered pair x and y is an element of x if x is less than y, to be considered as set x. And B, we should draw the diagram of T, whose elements are 2 and 1 and 2 and 5 only. Okay? Let's have the first relation, which is set S, relation S. So we have here set A, 1, 2, and 3. We have here set B, 1, 3, and 5. Okay? Remember that our condition should be x is less than y. So we have here 1, comma 3 because 1 is less than 3. We have 2, comma 3 because 2 is less than 3. We also have 1, comma 5 because 1 is less than 5. We also have 2, comma 5 because 2 is less than 5. So are there other ordered pairs that can be considered as relation S? Okay, not. So we have 1, 2, 3, and 4 elements of relation S. Okay, next, we should draw the relation T. Okay, relation T. Okay, let's have here set A, 1, 2, 3, and set B, 1, 3, and 5. The relation T must have only two elements. We have 2, comma 1 and 2, comma 5 only. So this is the arrow diagram of a relation. Let's proceed. A function f from a set A to set B is a relation with domain A and codomain B that satisfies the following two properties. So again, we are considering now the functions. Okay, so relation can be considered as function if we will satisfy these two properties. A relation f from A to B is a function if and only if every element of set A is the first element of an ordered pair for the relation f. So meaning to say, the element of set A could not be repeated to all first element of an ordered pair in a relation f, or that can be considered as function. Next, no two distinct ordered pairs in relation f have the same first element. So, parang same lang sila ng ibig sabihin. So, ibig sabihin, yung set, yung x values should not be repeated and unique as itself for all the first element. Okay? We also have this saying that all functions are relations, but not all relations are functions. So we can consider different sets as relations depending on the conditions and the given samples, but not all relations can be considered as functions because of the two properties that we have, that they must be applied or have in each relations. Okay. In other words, parang pag sa totoong buhay, lahat ng mga relasyon, lahat ng mga nagpo-functions ay may relations. For example, if we have mother and daughter, diba? If we have a strong relationship, it is considered as the relationship is functional. Okay? If you are still friends with your best friend since high school, kung same pa rin ang inyong bonding and relationship, even as time goes by, ibig sabihin, yung inyong relationship is functional. But, not all relations can be considered as functions because of many factors. Diba? Hindi lahat ng mag-boyfriend-girlfriend ay nag-work out ang kanilang relationships because they are not functioning to their responsibilities in each other. So, parang gano'n ang ibig sabihin niyan. I hope you understand. Let's proceed in this example. Kinds of or types of relations. As you can see here, letter A and letter B can be considered as function, and letter C is not function. It is only considered a relations. But all these three types are relations. Okay, let's try this set. The A 1 to, it should be 1 to 1. I'm sorry. So W is not there. It should be one-to-one functions. So it should have here that dash. One-to-one function. How can we consider that a relation is a one-to-one function? So let's try this. So 1, comma 1, 2, comma 3, and 3, comma 5. As you can see, if we will draw this in an arrow diagram, so the values of x are 1, 2, and 3. And the values of y are 1, 3, and 5. So as you can see, 1 is only for 1, 2 is only for 3, and 3 is only for 5. So there is 1 values of x corresponds to 1 values of y. That is a one-to-one function. Next, many-to-one function, so which means that there can be so many values of x to one value of y. Okay, so let's try it in an arrow diagram. So we have values of x which are 1, 2, and 3. And the values of y is only 3. So 1, comma 3, 2, comma 3, and 3, comma 3. So this is considered as function. Dahil x is there are no two distinct elements for the values of x. In number 3 or letter C, it's one to many. It's not functioning. Like in arrow diagram, we can see that here the values of x are 2, ah, only 2. 2 and the values of y are 1, 3, and 5. As you can see, values of x is repeated to any values of y. So this is not considered as function. Relation lang siya. To easily remember these types of relation, for example, if there is one man and one girl uh, na walang iba and things are getting better for them, it is considered as one-to-one and it's functional or it's functioning. The relationship is functioning. Many to one, why it is considered as function? Ano paano siya marerelate sa totoong buhay? In our country, or like in any other country, for example, X are the man and Y are, no, X are the girls and Y is a boy. Okay? So, in our country, Muslims can have one or more than one wife or more than, as long as he can handle it and he can provide for his families. Okay, so it is functioning or as long as kaya niya. And, diba, in a simple relationship, if a boy has many girls, then sometimes it's okay because it's their nature as a man. But in letter C, one to many. So if the X is the girl and Y is the considered as boy, if a girl or if a woman has many boys or many men in his life or in her life rather, it is not a good image for a woman. Ba? So parang hindi maganda. Parang masama ang feedback pagdating sa babae. Pero pag sa lalaki, we can suggest, ay, nature nila yan. So something like that. Okay? I hope you understand it deeper of what I have give you for this example of these types of relations. Another useful way to think of a function is a machine. So suppose f is a function from x to y and an input x is given. Imagine f to be a machine that processes x in a certain way to produce an output, or f of x, or simply y. This is illustrated below. So functions machines like this one. So if we will put something in a machine, so there will be the dependent output, or um, f of x. Okay, f of x is considered y din, ha? Then next, we have functions is defined by the formula. Okay, for example, the squaring function from r to r is defined by the formula f of x is equals to x squared for all real numbers of x. Like this example, if we have the value of x, which is equals to 7, then substituting it, we have f of 7 is equals to 7 squared, which is 49. So this is defined by the formula for the square. Next, we have here the successor. When we say successor, the next uh, sequence. Okay, the successor function from g from z to c is defined by the formula of g of n is equals to n plus 1. Okay, for example, if we have the value of n which is equals to 8, then 8 plus 1 is 9. So g of 8 is equal to 9. We also have what we call constant function. When we say constant, the value is not, the value is still the same. So for example, constant function h from q to z is defined by the formula h of r equals 2 for all rational numbers r. Even though we have the value of r which is 10, if the constant is 2, then h of 10 is equal to 2. Still the same answer because of the word constant. A function is an entity in its own right. It can be through a thought as a certain of a relationship between sets, or an input-output machine that operates according to certain rule. A relation is a subset of Cartesian product, and a function is a special kind of relation. Specifically, if two functions, f and g, are functions from set A to set B, then, okay, symbolically, we have function which is equals to uh, ordered pair x comma y is an element of A cross B such that y is equals to f of x and f of x for all x in A. So we have here, the next one is equality of a function. How do we consider that two functions are equal? Let's have this example, x plus 2 for f of x and 2x plus 4 over 2 is for g of x. Okay, thus f of x is equals to g of x. Let's try. So if we have f of x, again, uh, f of x is x plus 2 equals g of x is 2x plus 4 over 2. The g of x can be simply as simplified as 2 the product of x plus 2 all over 2, right? Because 2 times s is 2x, 2 times 2 is 4. So, parang ganun lang siya. Then, we can cancel the 2. We can say that this is simply x plus 2. So it means f of x is equal to g of x. Therefore, f of x is equals to g of x. So that is how the functions can be considered as equal functions. Okay, another one, f of x is equals to x plus 2, and g of x is x squared minus 4 over x plus 2. So f of x is a simplified expression, while g of x can be simplified. So f x squared minus 4 all over x plus 2. The factor of x squared minus 4 is simply x plus 2 over x minus 2. Then copy the denominator, x plus 2. So we can cancel this out. The answer is x minus 2. Is x plus 2 equal to x minus 2? No. Obviously, they are not equal. So therefore, f of x is not equal to g of x. Okay? So I hope you understand this topic, and you can chat in our uh, group chats if you have questions and queries about it. Okay? And thank you so much for listening, and I hope to see you on the next online meeting. Have a good day.